Well, welcome to the channel. My name's Tel, and today we're going to be looking at the Agon Light 2. So it arrived a few weeks back, quite a few weeks back actually, on my doorstep in this lovely looking box from the company I bought it from, which is OLIMEX, and they're based in Bulgaria. And I bought this for the princely sum, I think, of £59, which I believe was a good deal. And you probably will when you see what it's got inside it. The fastest 8-bit computer in the world, according to at least one source. But we're going to be doing more than just a review, as there are plenty of videos out there at the moment just reviewing the Agon Light. But I've been using it for a little while now, and I wanted to do a video on the good and less good things that I've found from my perspective for the kinds of things that I wanted the computer for. In addition to doing a review, I wanted to put together something practical to give us an example at the end. And I don't mean a flashing LED like you see in so many reviews that are done today. So the Agon Light is a fully open source, lightweight, 8-bit modern computer and part microcontroller actually in one nice little package in the palm of your hand. The hardware was designed by Bernardo Kastrup from a channel you may have heard of called the Byte Attic, and the firmware was developed by someone called Dean Belfield, I understand. Although it is allegedly the fastest 8-bit computer on the planet right now, I can't really validate that personally, but having said that, I have been using it and it is actually really fast in comparison with anything I've ever seen. And on top of that, it's really inexpensive. You can pick them up for around 60 UK pounds at the time of this video production in early 2024, whereas other 8-bit computers of similar sort of ambitions are much more expensive. So I hear you say, is this like an Arduino? No, it isn't like an Arduino, although it has got a set of GPIO pins like the Arduino and an I2C interface and other ways of extending it, but it's much more than that. Well, is it like a Raspberry Pi then? Well, in as much as it's a single board computer and has got a video output and a keyboard, yes, but in many more ways it's not like a Raspberry Pi at all, and it stands somewhere in between the two, and the objectives of the two are very much different really. So let's take a tour around the board and let's see what's actually in this device, shall we? So before we get started on the tour of the board, there are a few points I'd like to mention about the designers of the Agon Light board. And the great spirit in which the design and ethos of this computer seems to have been undertaken. So in using modern day computers, the use is so abstracted from the physical engineering which underpins it, they have little chance of actually working out what's going on under the covers by comparison to yesteryear, to the 18s. For example, you can't even get circuit diagrams right. Everyone complains about that these days when they're trying to fix PlayStations or Xboxes and stuff like that. You just can't get them. But back in the 80s, when the 8-bit home computer revolution took off, manufacturers would have either put the schematic in the back of a user manual or a service manual, for example, or make them available in some other way, allowing people to understand the subject and the machine that they'd bought, regular Joes like you and me, who would have been so excited to be able to delve down low and really understand how everything was put together and make it do amazing things. So in my opinion, it seems that this has been handled exceptionally well, not only by making the board an affordable 8-bit modern computer available to the masses with everything open source, but also with making it with easily available modern chips and to supply everything you need to understand what's been done on this computer. So they published the physical board layouts and more. This effectively means that an ecosystem, if you like, of support and innovation can flourish using modern day technology which wasn't available back in the day. Like today we have GitHub and a plethora of other services like PCB designs and forums and goodness knows what. So anyway, with that being said, I think that was the whole spirit of this board design. So let's take a look now physically on the board, starting with the underside, and then flip it over and look in the chips. And then we can just take a look at the schematics and make sense of what you've seen on the board. Right, so here's a tour of the back of the board. So you see these big white blobs here. They're just rubbery feet that come with the box from OLIMEX, which is quite handy. you know, because it keeps it off the desk. You don't want anything to short if you're just using the board naked on the desk, as it were. So let's sort of go around from the left hand top corner and work our way around here. Right, so at the top of the board, top left, you've got the reset button. That is a power on reset, but you can also effect a reset by using Ctrl-Alt-Delete on the keyboard, which is pretty handy. Then you've got power. So on this particular version of the board, the power comes in on the USB-C, which makes kind of sense to me anyway. The VGA output is next, and the VGA output is kind of retro, obviously, but I guess this is a retro board, so it kind of fits. Personally, I would have preferred to see a HDMI port on there, but that most likely would have incurred a larger board and perhaps more complexity. And you don't really need to do that, because if you don't want the VGA, you want HDMI, you can also always put a HDMI converter from VGA in, maybe £10 or £15 or something like that. The audio, there's two ways of listening to the audio. By default, this board came with the buzzer on the other side of the board disabled, but you can re-enable that, and then you can use that buzzer to listen to your music or your sounds coming out on the other side of the boards rather than the other connector, with having to find an audio amplifier to listen to the music. But I guess it might be nice if you're playing a lot of games. So that's what that is. That's a 3.5mm standard audio jack. The keyboard, so although this is using a USB type A connector, this won't work with the majority of keyboards that you'd normally have on your desktop or a tower computer. And the reason for that is it's not using USB protocol, it is using a standard PS2 protocol from back in the day. And like the HDMI versus the USB for the keyboard, if they were to have opted for a USB protocol, it would have meant much more in terms of complications, and you'd need more hardware to cope with it. So you're going to need a keyboard that runs PS2 protocol and is either a PS2 connector or a direct through on USB using PS2 protocol. Then you've got the micro SD. This is your mass storage. This is where all your files will reside, whether they be the operating system files, your games, or whatever they're going to put on it. But there's bags of room indeed. And then we have the access bus. So the access bus is an IC2 interface. The ZDI is only used for programming the Z80 processor, and it stands for Zilog Debugger Interface. Very unlikely the majority of you would use that. I certainly won't be using it. It's there if you need it, and there is Flash utility available, so if you were writing your own firmware, that's what you'd have to use. Here we have a battery. That is a connector for a lithium polymer battery. I'm not entirely sure how much charge current it's able to take out of the board, but it's there if you need it, and that means the board can operate for a period of time underneath a battery power. UNext is your upgrade extension. I think that probably comes from the UNext, and that's going to be for auxiliaries like OLED displays or temperature detectors or whatever you can think of really that you can fit into that interface. The next one is going to be GPIO. The GPIO has got a whole bunch general purpose GPIO pins running over, I think, 3 ports. It's B, C and D, I think, but one of them is only one from one port. You've got ground, 3.3 volts, and then 5 volts over there. So is the power here, provided here, has got suppression protection diodes, which is handy to protect it from surges. There's also a couple of micro SD interface pins here. I don't know how they interact with the ones that we're already using elsewhere for the micro SD. We'll have to have a look at that. Probably not going to worry too much about the finer detail of this. I'm just letting you know where things are and generally what they do. You know, I'd refer you to the hardware manual, which is pretty good and it's got a lot of information if you need to go down to that level at this point in time. And I think that's it for the back of the board, and then we'll turn it over, and when we turn it over you will see that there's only really the chips to talk about and a couple of links. Okay, so in the green box there we've got the EZ80 flash microcontroller, which has got an 8-bit data bus, an 8 or 24-bit addressing, depending on how you want to use it, and a very fast 18.4 MHz clock speed. For the GPIO pins, there's 9 modes of operation: digital in, digital out, open source with no pull-ups, and open source or drain. So in those cases you have to add a resistor. We got that one reserved, mode 5, and then we got either dual trigger, in other words on the rising and the falling edge, available on mode 6, and then port B, C and D can have pins using alternate modes. You need to look at the manual for that because it's too complex to be going into it at the moment. Right, and also a level sensitive, so it can trigger a change on the levels there and generate an interrupt for you to use. Finally, in mode 9 you can generate an interrupt on a rising or a falling edge. There's a UART on board, infrared encoded decoder, I don't think it's used here, and the SPI and I2C interfaces, 128k flash RAM on board. I think there's 4 megabyte as well. And then we got the Zilog debug interface, or JTAG, whatever they use. That's for programming debugging, which we've already spoken about. Right, so that's that. Let's move on. So now we're looking at, in the green box, which is illuminated, 512k static asynchronous RAM, and that is used by the Z80 microcontroller. It's very high speed actually, it's got a really fast access time, as you can see there, and quite a relatively small milliwatt power draw there, and 7 milliwatt standby. Okay, so next up is the ESP32 Pico D4 microcontroller, and this basically hands the whole terminal subsystem, if you like, which includes the video, includes the keyboard, and whatever else it needs to deal with. It has got actually a Wi-Fi built into it, looking at the datasheet, but we don't appear to use that from what I can tell from looking at the circuit diagram, which seems a bit strange. I'm not 100% sure about that, but it doesn't appear to anyway on the surface of it. So, but you can get those add-ons through the Unix connector anyway. So this is a CH340T. It's a bus converter and it bridges the USB port to the ESP32 Pico D4. That's its job. So encapsulated in the green block now, you can see the buzzer on the left, that big round thing, and then you've got the buzz enabled. That won't be switched on, that link, normally when you've received this board, but I've got it plugged in at the moment because I'm not using an audio output. So that's all there is to say about that, and the other ones you don't need to worry about really at the moment. Right, so we're going to have a look at the block diagram now instead of going and having a look at the circuit diagram, because I think it makes a lot more simple sense actually after having looked through it. So it's split up into two sides really. You've got the main processing and GPIO stroke access. On the right hand side you've got the visual display processor and the general terminal I/O. So the left hand side is handled by the Z80 F92, which is a very able microcontroller, and that runs at 18.432 megahertz I think, and this side is running at up to 240 meg. So let's go through this side first. So we've got the controller there and 512k of really fast, very fast as you saw, SRAM with ECC error correcting memory. The ZDI port for debugging, or maybe JTAG possibly, 64 gigabyte USD card, which is our mass storage, and it always makes me chuckle when I say mass storage when I'm talking about 64 gig. But to a retro piece of kit using modern stuff, that's still a lot. So we've got the access bus, which we've already seen, and we've got the access bus port and the I2C and the general input output pins. On the right hand side we've got the VGA, which is T640 by 480, 64 colours, audio jack and buzzer there, and the keyboard, as you know, comes through a USB port, and it goes through this CH340 bridge to get to the Pico. In fact, most dev kits have got a CH340 or whatever the equivalent is, you know, to do that bridge between the USB levels. And then there's a high-speed line which connects the two and allows them to communicate and do all the things that they need to do. I know that's very sort of wishy-washy, but I can't really explain it in 5 minutes. Partially because I don't know it all, but that's running just over 1 megabit I think in speed, so that's pretty fast, and it still manages to do an amazing job really from what I've seen so far. So really that's all there is in terms of the board layout, where everything is, you know, on an individual chip level, some explanation of what the specs are, and then how it all hangs together. So that's covered the hardware pretty much. So what I want to do now is go and do an example which I spoke to you about at the beginning actually of the video, which will be a game which I've written which has a physical presence in the real world, and you'll see what that means when we come to it. It's not masses of code, it's all in BBC Basic, but it's something quite simple, but I think you'll find it quite fun if you decide to build it. Anyway, so let's get on with the fun part. But before we get into that, I would like to ask you if you can like and subscribe if you're not already a subscriber, because these videos do take an awful lot of effort to do, and I would really appreciate it if you have already subscribed that you do it, so you can see more videos from me on like subjects. So welcome to the software section of this video before we actually get into the game. So I'm going to spend just a short amount of time going through a few things about the operating system and also BBC Basic. So this is basically just been rebooted, and at the top of the screen you can see the Agon Quark VDP Visual Display Processor version 1.03, and also for the machine operating system the MOS. And underneath that you see the BBC Basic Z80 and the copyright RT Russell 1987. So if you don't know who RT Russell is, he was around in the early part of the 80s when Acorn was producing the BBC microcomputer for the BBC Corporation. And from what I read, he was working for the BBC Corporation itself. In 1987, according to my research, he created BBC Basic for Windows, BBC Basic for DOS. I don't know what he did in the middle, 1987 and now. So that's what I found out in my research. I mean, I've seen his documentation over the years anyway, so he was quite prominent. So the board doesn't come with any firmware, you have to download it from a site, for which I'll put a link in the description section of the video underneath. So currently we're in the BBC Basic, but to get to the operating system MOS commands, just do this. You can do it by typing in the operating system star, which means you're going to invoke an MOS command, and then going by. You wouldn't have that problem because it's not installed for you yet if you got a new one. But I actually put the commands to load up BBC Basic in something called autoexec.txt, and that is like a batch file that you'd see in DOS, for example. MS-DOS, if anyone remembers that so long ago. And that just executes a series of commands really. It's just a regular startup batch file basically. So in order to load BASIC and run it, there are two ways to do it. So I'm going to show you another command, just the dot, which gives me a listing for the current directory, which just happens to be the root directory. Or I can do a cat, which is basically catalog. So the dot and the catalog do the same thing. It's just a shortcut. So in there we've got a directory called DCIM, a test directory which I put in earlier, the MOS Basic, which is another directory that I created earlier, and BBC Basic.bin. That's the binary file which we need to load into memory and run. So I'll do it the slow way first, right? So we'll do load BBC Basic.bin. And it's loaded, and now I can just go run. Right, and we're in the basic prompt, and I can go back by going out of there again. I'll just type in run. Well, actually what I'll do is I'll do a Control-Alt-Delete, so we'll do a soft reset. So I will now do a run BBC Basic.bin. Oh, I should just go straight into it, so it loads it and runs it. So those are the two ways of doing that. Alright, so let's go through a few commands. We've done the load. We can make a directory from within BASIC actually. So if I do mkdir test2, now I'll do a startup. It's created test2 directory. I can also delete that. Delete test2. It's allowed me to delete that because there's nothing in it. If there was something in it, you'd have to remove those files first. So let's just change into the test directory, and then I'll do a star. And that shows you a basic file called temp-convert.txt, which I wrote today. And it's just a temperature converter, so I just knocked that up real quick. So in order to load that, we can type load, and this time it has to be in quotes. Temp hyphen, I forgot to change that. So load temp-convert.txt. In BBC Basic, every command keyword has to be in uppercase. I guess some people get used to it. Anyway, I can now do a listing, right? So to do a list, I can type in list. I can do a CLS because I'm in Basic, or I can do LI, and that will do the same thing. If it's a long listing, if I do a Control N before I do the listing, it will allow me to fill the screen, and then press the Shift key, and then do the next screen full, and so on. And then if you want to take that out, it would be a Control O. But I don't have a long enough listing here on the screen to do that. Maybe I'll show you in a while. So there's something else we can do. We can do with li dot. We can do if. Whatever comes after the if, it will filter that term and only have that in there. So if I just wanted the print statements, it's showing me all the print statements. Not particularly useful. But if I did an li dot if def proc, it showed me the two procedures. Now, if you're working with a lot of text, that's quite useful. What I'm going to do now is I'm just going to run this. So it's just a little simple Celsius to Fahrenheit converter. So it's asking me whether I put in a C or an F. So let's go from C, which is about one of the coldest days this year today. We'll put in 6 degrees. So that's telling me it's only 42.8 degrees Fahrenheit. Well, there you go. So I'm just going to escape out of there. Let's just have a quick look at the code because we can get it all on one page. Okay, so for those of you who have programmed in BASIC before, I mean old school BASIC, you'll probably remember the go-tos and go-subs. Well, BBC Basic also introduces procedures, right? And they're called proc. It's defined proc and then the name of the procedure. And also for functions, it's an FN. So define def fn and then the name of the function. These functions and procedures can also take in parameters as well, which is something that we never had before, and everything was kind of global. Well, it still is a bit global. It depends on how you use it. So that was a big improvement. So what I found was programming in BASIC is something that I don't do much, and so I keep wishing that I had some of the facilities that I would normally get in C++. But it is what it is, and we have to get used to it if you're going to do it. Yeah, so I knocked this one out today pretty quickly because I just wanted to use it as a test vehicle for the video, really. At the top you can see the header, tells bench, 26th of Feb. And all it is a Celsius to Fahrenheit and backwards converter for the Agon Light 2. And I'll demonstrate it in just one moment. So I'll put in C for Celsius, and it's very cold at the moment, so 7 degrees. Let's see how much it is in Fahrenheit. So we've got a balmy 44.6 degrees Fahrenheit there. That's amazing, isn't it? So we'll do it in the other direction, 90 to 99 degrees, and see what we get in Celsius. Right, 99 degrees. It tells me that's 37, so that's really hot, isn't it? Remember the summer last year when we had ridiculous temperatures? Europe and those sort of Eastern Southern European countries were pretty much on fire, a lot of them, even on the Canary Islands and Tenerife, I think it was. Anyway, that's another story for another day. So let's do a CLS. So on the list again, do LI with a dot. That will give you the same thing. So that's a dot is a sort of shortcut. LI I can have up to 50. So give me anything up to 50. Oh, LI dot 50. So that will give me 1. Right. That's peculiar, isn't it? Because I only gave it one thing. So list up to 50. So everything up to 50, and I can do list everything after 50, or in between, say 50 to 100, right? Or list 100 onwards. So what else have we got here? If we wanted to edit something, and actually we've got a problem, in as much as we've got 1 star more than we really should have there at the top. So I could do one of two things. I could either remove 30, or I could edit. Edit line 30. So I can go and put a load of these in, and then I can actually take out 40. 40 without anything on there is going to delete the line. and I list it again, and you can see that now looks right. So if I run it, it should have a little bumble up the top of there on the left hand side, and that looks better. The right hand side's open, but that's by design. That's what I say anyway, for which there's going to be loads. Now that is a nice handy inline editor. There are other editors available, and you're going to find things like AED, I think. If you just do a search for Agon Light AED editor, you can use that. I haven't got it installed in there because I've been doing most of my editing on Notepad, believe it or not, and then testing stuff out. Yeah, so there's a few things about changes that are in there, but there are more changes than that, and I'll come on to those when we do the game. So let's clear that screen. And let's see what else I need to tell you about. Right, so let's just check. So I can save now this to my file, because I've made a change now, right? I made a change up the top. I changed the header on the top, so I need to change that to temp-convert.txt. Now if I do a new, which gets rid of everything in there, I can prove that that's gone. For this, there's nothing there. I now can load temp convert. Should have made this file name smaller. .txt, and there's a little delay and it loads it. Right, the text.txt files are purely stored in ASCII, so you can transport this out of this or one in that you've done somewhere else. Now I can save over the existing name with that. Do a cat star. Right, I haven't got anything else in there, but maybe I want to save that as basic, right? So if I do a save temp convert .bbc and do a directory, now that shows me I've got a BBC file. Now let's CLS and let's list the file again. So I'm going to edit a file there, and I'm going to put something in on line 5 which isn't going to do any damage, just a rem statement and nothing else. Save as temp convert.bbc. temp convert. Right, so if I do a star dot there, temp convert.bbc, if I save with the same file name again, temp convert.bbc, it will come up with access denied. I'm not entirely sure the reason for that, but this is just something it does. I need to dig into that and find out why it does that. So if you can save it again and again to the same file if it's text file, but if you save it as BBC Basic, then yeah, that will give you an access denied. You certainly used to be able to save the same BBC file before on the BBC, so I don't know why it doesn't work, but I guess we'll find out. Somebody might know, and if you do know, leave a note in the comments. Right, so this is the bit we've all been waiting for, or I've been waiting for anyway, for some time. It's to show you this game. Some of you might recognise this kind of thing. It looks like a sinusoidal wave of some sort with some distortion or modulation on it, but it's actually just an old coat hanger that I've bent into some weird shapes. Now this game you would have seen in a typical sort of fete or village fair type of thing back in the day, and kids would play it and see if they could actually get from one side to the other without the buzzer going off. So I want to redo that game for the Agon Light, but the purpose of that is to exercise the GPIO pins, and I didn't want to use the standard flashing LED. I wanted to do something a bit more interesting. So this is all reclaimed parts. So as I say, that's an old coat hanger, a couple of bits of metal circle, and the wand is an old paintbrush which I cut in half, and that is a piece of the coat hanger that was left over. This is a mains cable from the sort of domestic 240 volt supply. Obviously there's no 240 volts in there, but to connect this to the Agon Light I had to do something, so I used this old cable from a Sega Mega Drive, or Sega Genesis if you're in the States, which has got a broken wire in it, but it's fine because I can use the other wire, so it's good enough to work. This is a disused drive case, so if I just take the top off of there, and in here, oh, I don't know how clear it is under there, in there you can see the wiring, so maybe it's better if we just have a look at it there. So there's a small piece of Vero board on here, and we've got this 90-degree 34-pin edge connector, so that a IDC cable plugs into that, and that goes straight into the back of the Agon Light. On reflection afterwards, I could have used the smaller one. So there's a smaller one with 3 pins in. I could have used that, but so there's ground, 3.3 volts, and 3 connector cables for this terminal. This is a terminal, and this left one is a terminal, or tab. I'm going to call these tabs. Okay, so to make sure that they don't float, I've had to tie these up to 3 pins. I've tied that up to the plus 3 bolts, so that will prevent it, you know, floating around and doing unexpected things. So all that happens is when we connect to the buzz wire or one of these tabs, it will ground them, and that will have an effect because we'll be monitoring those inside the Agon Light and doing something appropriate at that time. So on the back of it, I'll just show you the back of this if I can. It's a bit rough, right? So I gouged the channel out and the cabling goes through there, but I didn't want to cover it up with a plate at this point. I wanted to make sure it works and everything, but I'm going to cover this up with a plate, so nobody's going to get electrocuted or anything, but it's just be nicer and neater. So what I'm going to do now is I'm going to button this back up again and connect it to the Agon Light, and then we'll go through very quickly, because there's not much to it. We'll go through the circuit diagram for this buzz unit controller, and then have a quick look at the code, and it will be a quick look because the only thing I want to do is zoom in on the code specifically that deals with the GPIO, because I want to show you how that works, and then we'll go on and we'll do a real live demo of me trying to win the game. This is the circuit diagram for the buzz controller, which you've just seen, and as I promised you, it is very, very simple. So this is a physical representation of the controller itself, where you've got the insulators there, so that when the one comes down, it will be able to touch the 2 tabs, left and right, but won't be interfering with the buzz wire at that point. And there's the end of the 9-pin D-type and all the connections. So see, 3.3 isn't actually used at all, but it does go there. And then there's the cable goes to the 9-pin male, which is in our little X disc case that I showed you, and these are the lines where they're pulled up to 3.3 volt with a 10k resistor to stop them floating, and they go into port C 0, 2, 4. The reason that they go in this odd number, it's the right side of the connector to connect to. It just makes it easier really, and nothing else. And then ground. And that is it. That's all it is. Now, if I was doing this for a commercial venture, which I'm not, I would change this design to have some opto-couplers in here so that it was completely isolated. There is a small possibility that if you were mad enough to go and put a voltage on this wire, that you could do some damage, but I'm just going to assume that everybody that's going to watch this is very sensible and won't be wearing big nylon jumpers and going around rubbing their feet on the carpet to get to 1,000,000 volts before they try this out. There is some pin protection on the power supply, but of course we're not really using the power supply, that this is going into the pins. So just a bit of common sense really. So let's go and have a look at the code. So up the top of the code, I've set the import to 158. So 158 is port C, and the DDR data direction is 159. So we're going to put 255 to the data direction register, so that's port C, and we're going to make that 255. It means all those ports pins on there are going to be input pins. So on the EZ80, the direction is 1 for an input and it's 0 for an output on the data direction. That's it really. So that's effectively defining those values and putting a name to it. And then we go down to, I've called it defines. I haven't got defines. There's no such thing in BBC Basic, but I've just assigned them to variables. So in there we've got the buzz, right? So that's the buzz pin, and that's 254. That's the value you're looking for on that byte. Alright, 251, that's the left tab, and 239 is the right tab. Probably actually thinking about it, I probably should have, on the data direction, I should probably have made the other ones outputs, not inputs, but I'm not going to worry about that now. So that explains to you how that works. Okay, so we pick in port C, we set up, so that's our input is on port C, that's the direction register, and then we put the value of 255 in there, so that sets them all to in. It seems to work alright, so I'm not going to really worry about it at the moment. And then we define them down there. So I'm not going to go through all the code. We have a little repeating loop there. We give you the header and the instructions, which you'll see when we boot this program up. And then we just get into this repeating loop really forever. So we do a get import. Right, so get is a new variant of the command from the original one, because you can actually give it the import and it will return the value of it. Command, which is just looking at the import, right? So it's just going out and getting it. Where you see this rem key there, that's when I was testing it on a keyboard, on an emulator, but I've just left that in at the moment just in case I need it again. And then we just loop round until we've either got the target, so the target depends on what's happening in the game, is it the left tab or the right tab, and then we've got the buzz. Right, the buzz wire itself. So we're only expecting the one of those two things, the target, it'll be one of the tabs, and the buzz wire. If we get that, and if we got the buzz, right, then it's a player result is false, that means they lost. And if it's a true, then they won, because it means they hit the target. And then we just got some game stats there that we're showing. So this can be a game up to 2 players, depending on what you set in this kind of defines up here. So if you set the number of players, we've got a number of players there, if you set that to 1, then you'll only ever get you playing. If you set it to 2, like you've got a couple of kids or you want to play with a friend, you know, you just set that to 2 player. So it will ask you that, that by default, but it will ask you that when you start the game up. So you don't have to go in and physically change this, because it will ask you. So that this was defaulted to 1 when I started to write the code. Sorry, to 2 when I started to write the code, and then I put in the routine to actually ask the player what they want when the game starts. So that's really all I want to show you in there. Alright, so that's it now. So let's go and play the game. Okay, so it's asking me for the number of players I want. 1 or 2, so we're going to take 2. Start the game by tapping the closest left or right tab. So let me go down there. Okay, so it's asking me to advance to the right tab, so I'm going to probably fail this. Oh, I failed it. So it's saying you lost. Go all the way to the right tab. It's telling me I've lost again. It's giving me the stats. And then it's going to say advance to the left tab, so this way. We've done it again. This time I'm going to be really careful, okay? Go to the right tab. I'm going to be very careful. This is going to take me a bit more time to do it. I think the trick is when you go around these curves, to keep the wrist in one position, twist the fingers. This is so difficult. I thought it would be easier than it is. I'm trying to keep my concentration here and talk and watch the screen as well and do this. Oh my god, I might just make it. Wow, yeah, I won. Did you hear that tune? That was wonderful, wasn't it? Okay, that proves to you that this works. I've really enjoyed doing this video, and I'd like you to subscribe and like the video if you don't mind, if you've enjoyed the video and you found it useful. Because I'm a small channel, it's a very small channel, and I'm trying to grow it, and every subscription and every like really helps. And I will see you next time.
It's gonna be alright.